Welcome to Solutions Studio. This is a free series on C programming language. If you like these videos, please subscribe to follow along with this series. Also, please like and leave a comment and share the video to help spread this series. Hello and welcome to this episode, and in this episode we would like to briefly discuss about streams in C programming language. So basically, what is streams? Inputs and outputs that are performed with sequences of bytes, they are called streams. And we have two types of streams, input stream and output stream. In the operation of input streams, the bytes flow into main memory from a device such as a keyboard, a solid-state drive, a network connection, or so on. And in the operation of output streams, bytes flow from main memory to a device such as computer screens or a printer or a solid-state drive, a network connection, and so on. And by default, when a program execution begins, the program has access to three main streams. The standard input stream, which is connected to the keyboard by default, the standard output stream, which is connected to the screen by default, and the standard error stream, which is also connected to the screen. And also it's worth mentioning that operating systems allow these streams to be redirected to other devices, but as we said before, we have the default ones, which is basically the keyboard and the screen. Stay tuned with us as we go into in-depth detail of streams in the coming episodes. Hello and welcome to this episode, and in this episode let's go and discuss the formatting of outputs with printf. As you have seen that we have used printf in many of our previous programs, and in fact printf is one of the most used functions in C programming language. Now every printf call contains a format control string that describes the output format. So you may recall from the previous episodes that we would initialize, for example, a variable, and then we would use the printf and the format control string to be able to print that variable. Now the format control string, which is basically this part, could consist of conversion specifier, it consists flags, field widths, precisions, and literal characters. And together with the % sign, these will form the conversion specifications. So basically, this is a conversion specification, but in its very simplest form. In fact, it could include more details such as flags, field widths, precisions, and so on. And in this part, let's go and have an overview of the functions that we can perform with a printf. So printf has these capabilities such as rounding floating point values, aligning columns of numbers at their decimal points, right aligning and left aligning, inserting literal characters at precise locations of a line of output, representing floating point numbers in exponential format, representing unsigned integers in octal and hexadecimal format, and displaying data with fixed size, field widths, and precisions. Now we would discuss all of these capabilities and how to use them in the coming episodes, so stay tuned with us. But now let's go and see the printf function, the general form of the printf function, which is basically the function itself, and then the format control string, as we said before, like this in here, and the other additional arguments that we might have. And basically the task of the format control string is to describe the output format, and the optional other arguments correspond to the format control string's conversion specifications. Every conversion specification begins with a % sign. So as soon as you see a % sign, that means that a conversion specification has begun. And it always ends with a conversion specifier. And as you can see, this is a conversion specifier. But we can have many more details between the % sign and the conversion specifiers, including flags, field weights, precisions, and literal characters. And there could be many conversion specifications in one format control string. So we're not really limited to one conversion specification in a format control string, but rather we can have more conversion specification. For example, I can add more and I can add more arguments as well. Stay tuned as we go into in-depth details of formatting output with printf in the coming episodes. Hello and welcome to this episode, and in this episode we are discussing on how to print integers. So an integer is a whole number such as 776 or 0 or -52. They're whole numbers. That means that they don't have a floating point values. And integer values, we can display them in several formats that are described here using this table. This table is actually showing the integer conversion specifiers that are listed in here and the description of those specifiers in here. So basically, D is to display a signed decimal integer, I for a signed decimal integer as well, O for unassigned octal integer, U for unassigned decimal integer, lowercase x or uppercase x displays an unassigned hexadecimal integer. And as you can see that if we use the capital X, the uppercase letters will be used, and if we use the lowercase x, the lowercase letters will be used. We also have these length modifiers that are placed before any integer conversion specifier to indicate that the value to display is a short or a long integer, such as H, L, and LL. Now let's go and see some examples in here. To understand how these examples work, let's go and run this program first. And then now we can elaborate on these examples. You can see that we are trying to print 455 using the format specifier D, which has been used and it has printed 455. I has been used as well, and it's basically the same as D. We also have D, and we also have a positive sign in here, but as you know that just like the real world, we usually don't print the positive sign. But in case if it is a negative value, we always print the negative alongside the number. Then we have this HD, which H is a length specifier and D is basically the type of the integer. Then we also have LD, which is basically indicating a long integer, and we have this a long number and at the end L. This L suffix on this integer literal indicates that this integer is of type long, and that L is not going to be printed on the result. Now we have used the conversion specifier of O, which is basically used for printing octal values, and this integer value of decimal has been converted to octal in here. Then we have the unassigned integer, which is basically in here. And using the unassigned integer, as you can see that we have tried to print a signed integer using unassigned conversion specifier, and that's why we have got this value. The reason why we have got this value has to do with the underlying binary representation of numbers inside the computer that we will discuss maybe later on in the coming episodes. Then we have the conversion specifier X, which we usually use for hexadecimal numbers, and the capital letter X, which is also used for hexadecimal letters. And here C is lowercase because of the lower X in here, and in here C is uppercase because of the uppercase X in here. And that's it for this episode. I hope this has been informative for you, and I would like to see you in the coming episodes. Stay tuned.